Welcome to the Visual MODFLOW Flex What's New webinar. We'll be going over some of the main features that we've introduced with version 5. The main new feature that we're excited to introduce with version 5 is that we've added support for the SEAWAT engine. It's based on MODFLOW 2000 and MT3DMS. It's fully coupled, and it's a variable density groundwater flow and heat transport model. The two packages, that, if you're not familiar with SEAWAT, that link MT3DMS with MODFLOW 2000 are the VDF and VSC packages. The first is variable density and the second is viscosity. So let's pop over to Flex and take a quick look at how SEAWAT's been implemented. The first, on the conceptual side, if you go to the define modeling objectives step, you'll choose the flow type that's saturated with variable density. And you'll notice, I'll make the screen just a little bit bigger, that a bunch of species parameters will pop up. The first thing to note is that you should choose your first species as salt, or whichever species is the density driving solute. In most cases, this will be salt. And then you'll have your standard initial concentrations, but you'll also have some SEAWAT specific fields that pop up. The first is the reference concentration that drives where the reference density is set. And then the density is driven by the density slope, which is d rho dc, which is the change in density versus the change in concentration. And then you'll also have a similar relationship for the change in viscosity, d mu, over dc, the concentration. There's also species-specific diffusion coefficients, and that's really important mostly just for when you're adding temperature as a solute or as a species to be modeled in a SEAWAT run. The way you turn on temperature is you name a species, anyone other than species 1, as temperature, and then you check this box right here that will turn all your units into degrees C. Celsius is the unit that's been hard-coded into SEAWAT, so we only have that option available at the moment. And so you would set all your parameters there. There's not much SEAWAT specific in the model parameters unless you start playing with the retardation model. So you go there and you can fill out your model on the conceptual side, and then coming over to the numeric side, if you go back to your modeling objectives, you'll see that the modeling objectives are the same on the numeric side. The main difference is that we have introduced some advanced settings. Now these are actually available for all engines, and what it is a series of general options for each package that's supported. And these basically allow you to turn translation and running on and off, similar to what we offered in the classic interface. So you can go through and say for your constant head package, you can either choose to run it or translate it. If you have your own CHD file that you've developed outside of Flex, you can choose to not translate that and then run it anyways. And then as long as it's named the same as your model base name plus CHD in the same folder, then it will run with that user-supplied input package. We also have added similar support to allow you to introduce your own packages that we don't quite support yet. So for instance, the drain return package, DRT, we don't actually translate it yet, but you are able to run it if you've created your own. On the SEAWAT side, though, what's new is the VDF package has some package-specific advanced options, the most important one of which is the density option, which allows you to choose which solute or solutes are driving the density relationships between flow and transport. So the first option, the simplest option, is to just calculate density from salt, which is assumed to be species 1. The second option is to calculate density from multiple species, and that's any species that has a non-zero density slope from the modeling objectives page. And then the final option is to select an uncoupled simulation using a pre-calculated density value. So in that case, you'd be either using the reference density or a density that you supply through the UCN file, maybe from a previous run. There are some other options that you can either choose implicit coupling or explicit coupling and change those options as meets your needs. And if we go back to the multiple species, you'll see that has more or less the most options. So there's min and max fluid densities that set upper and lower limits on what the calculated density will be for your model. There's also the reference fluid density, which is where your reference concentration and your reference density have a one-to-one relationship. And everything that departs from that is based on that density versus concentration slope. And then there's a convergence criterion that controls how the looping solver between flow and transport handles density. Similarly, for the viscosity package, there's a viscosity option that allows you to choose which species control viscosity. Viscosity itself is actually an optional package, so you can choose to run it or not. And viscosity tends to increase your model runtimes fairly significantly. So unless you're dealing with fairly wide temperature ranges or high solute concentration ranges, it may be advisable to avoid this package unless you really need high degrees of accuracy or precision on your model runs. There are 4 options that are temperature related. So when you select the temperature species back on the modeling objectives page, so we'll go back there and just remind you, this checkbox right here. If you've selected a temperature species, then you'll be able to select one of these relationships that are built into SEAWAT between temperature and viscosity. And other than that, everything is more or less the same for what you do with a standard MODFLOW and MT3D-MS run. So this model just shows you freshwater injection on the left or western edge towards saline constant head boundary condition on the right. We'll go to the next major feature, which is RT3D. And so we've also introduced the RT3D engine. The main 6 reaction modules that are part of RT3D have been added in and supported. So we'll go back into Flex and let me load up another simple model. That way we're not waiting too long. Okay, so if we go into the modeling objectives page, this is where you would pretty much set up your RT3D run. It's going to look virtually the same between the conceptual and numerical side, so we'll just look at the numerical side for now. Where you would select your RT3D reactions is in the reaction tab right here. Make sure your transport is active. And the bottom 6 options right here are the RT3D specific options for reaction modules. So for this particular model, we've chosen the sequential first order decay, which is the sequential decay between PCE all the way down to vinyl chloride. The options that are sort of new are these tolerances. So there's an absolute tolerance and a relative tolerance. That's pretty well documented in the RT3D manual. And then where most of what you'll be looking at in terms of the modeling objectives are in the model parameter side of things. So you'll have a bunch of reaction parameters. Some of these are constants. In the case of these yield coefficients, those are typically constant and not distributed over your entire model, whereas the degradation rates can be distributed over your model domain on a cell-by-cell basis. Going through here to the single run step, you'll notice that based on the modeling objectives that RT3D is the transport engine that's selected. And then you can go to the translate step, and you'll notice here that there's MODFLOW 2005 with the advanced settings, and RT3D also with advanced settings. These are virtually identical to what you would have seen with MT3D-MS. So I'm not going to bother running the model. Again, it would take quite a while to go through that. And let me turn on the model tree. And you can see that you can loop through the species. So we're injecting PCE through an injection well. Not something you really want to do, but just for a demonstration model, it serves the purpose. So you can see the solutes during the model simulation. More generalized options. One of the bigger ones that people have been asking for a little while has been the cell inspector. So we've introduced that, and I'll show that in the demo shortly. I'll go through this page and then show you all those features. The status bar has a few more parameters, and we're still tweaking that a little bit. We're actually working on a little bit of a patch that's coming up to add in just a couple more features later this month or maybe in early March. So we'll go over that. There's in the USG model runs, we've added the layer picker and the time picker, so you can look at that now, and it's available in all the viewers. And then in terms of workflows, we've already gone over the advanced translation settings, but those are now available for all the supported engines. And then there's property and boundary condition tools we've added in a field calculator, and I'll demonstrate that shortly as well. So let's go back to Flex. So the first one is the cell inspector. So in any of the viewers associated with a workflow, the cell inspector will show up right here in your toolbar. You can click on it, and it'll pop up a new window that's the cell inspector window that's specific to your particular run. So it'll be the name of the grid dash the name of the run, and it can call any information within that model run into this window. So on the select item side, it shows all the available parameters, both information about the grid, all the properties, boundary conditions, and outputs. So in order to simplify this, let's pare this down a little bit, and we'll just look at the output concentrations. So if I have my grid on, and I need to make sure that the grid is on as an object, then you can actually select the items. And it's probably easier to see in this group view, and we'll explain the list view in a second. The group view, what it allows you to do is just have everything grouped by whether it's position or output or boundary condition, and then you can see the values as you click. The values now are not live hovering. You have to click on one area in the model, and then you can keep these values in the cell inspector. The other neat thing is if you go into the list view, you can do a select all and copy, and then paste that into either Notepad or Excel or some other place so you can share them or make some side calculations if you like. The cell inspector is linked to the time picker, so whatever time that was available in this time picker up here, when you clicked, is what's going to be shown in the cell inspector. And you can change that. If I go to 7:30 and click again, then it's going to update with the new value. Also for the position, for the IJK indices for your cell, you can actually change the numbers. If you have a particular cell that you actually want, and rather than having to find it on the screen, you can just type it in and it'll update and requery the cell inspector for you. If you add in new boundary conditions while the cell inspector is open, then you just need to click the refresh values. Or if you've changed anything, then the refresh values button will work for you on that. The next feature is the status bar. Your status bar is actually going to look a little bit different. This is the dev version, maybe a sneak peek on what's coming in the patch. So in the preferences here, I think everything is turned on by default now. In this version, you'll be able to turn things on and off. And we've added in the dimensions of the cell. So you have the width, the length, and the thickness of a given cell. For an unstructured grid, it's just going to be the area and the thickness and the volume. And then you also have the attributes. So if I have vinyl chloride as my active layer, then it'll show up. You can see that we've got the layer, the row, the column, the centroid, or the X and Y coordinate, and then some information about the cell that's in there. Since this is a uniform grid, those pieces of information aren't changing, but you notice that everything else is. The field calculator. If we go over into a boundary condition, and we edit a boundary condition, there's now an expression builder. And so what you can do is select, I'll go back up just a little bit. So there's a button right here that will call the expression builder. And what you can use that for is to build in some variable names. So if you want to say the cell bottom and +1, then you can do that. This model is fairly simple, so it's probably just going to come in as 0 + 1 since it's flat. But if I click on the starting heads and then go back to the calculation and then do fill, it'll automatically do that. I can also add in any of these other variables, and in an upcoming release we'll be adding in pretty much all the variables that you had back in Classic. For instance, for the river cell, you could choose the river stage or the river bottom and then use that value. So if you've already got your stage, if you know the depth of your river, then you could subtract that off of the bottom and it's dynamic so that it'll fill for each cell according to that variable. There's also just some general math functions and a little bit of logic function as well. That's it for the property and boundary condition tools. There's also, if I close this model, there's now an easier way to import your Classic model. So if you want to import a project, you go straight to File and Import. So if I choose this Classic project right here, I can open that up and then choose whichever data repository you want and whether or not you want to create a folder, and then it'll import the entire project for you. So it saves you quite a few steps. So you're able to import your entire project. You're also able to import concentrations. So if we go over here, you'll notice that if I go to edit the boundary condition, and there's a species here, and it actually has non-zero concentrations. So you can now import all your transport parameters as well. Another thing that you're able to do now is also rename objects in the model tree and in the model explorer. So if you go here, you can actually rename values. Let's just call it north 1, just to prove the point. And so it's there. And you can also rename surfaces or any object in the data tree. So if I want to call it 5, I can. You could create folders before, but you're able to name them now. So say you had a folder you wanted to call surfaces, you can do that, and then you can drag your objects in there and reorganize them. So then it makes the data folder a little bit cleaner from what it was in the past. The only real restrictions on renaming are there's certain properties in the model tree that can't be renamed, including the conceptual model, and unfortunately the model runs in grids, and that's just because they're tied to the folder structure in Explorer, or your actual operating system folder structure. Feedback has now been moved right here, so if you have any feedback, you can put it in directly to us. What will happen if you click on the thumbs up or thumbs down is there's a little box that you can just type in a comment. This doesn't get monitored that frequently, so if you have a support question, please send email directly to support. But if you just have a feature request or something that you think would improve the program, then we're listening and we want to hear from you. So you can type in a suggestion or a comment or anything like that, whether thumbs up or thumbs down. We want to hear all feedback, and then you can send it. And this is fully anonymous, so you can choose to include your name and contact information or not. Those are pretty much the new features. The other main one to note is that we've added in the SAMG solver for pro users as a single core solver. So the premium version still has the multi-core solver, but pro users now can leverage the single core version of SAMG, which is still significantly faster than some of the other solvers. So with that pretty much takes us through all of the new features. All the new features are in the README file. There's a link right here. So if you're a little bit more interested in the minutiae of all the things we've changed, you can go there.
With that, this concludes the webinar. Thank you very much for your time, and have a great day.